Okay, I don't know how many of you will have difficulty with this lab. It's very similar to the one we did last week. That's one of the reasons we did it. In this particular lab, you are giving this, really it's a cool lab. It's a cool idea. There are these different components, and they're not atoms. They are molecules within the molecule. So pieces that make up this complicated compound that you are analyzing for. And we're going to figure out what the X, Y, and Z, how many moles there are of each of these components in this molecule by the end of next week. So this week, we're focusing only on B, and we're calling it B because it's a base, which means that a base reacts with an acid to give, not always water, that's one we did last week, H plus OH minus to give water. It can just give a neutral compound. And that's what's going on here, and that's all you're being asked to do. We're going to put this compound in water, dissolve it. B is going to become its own molecule that floats around in the water, and we're going to titrate it against HCl, just like last week. So this first part, how many moles of HCl is used, this is question 1 here, is, well, we know we have, 0.16, I'm sorry, it's 16.89, so it's going to be 0.1689 liters, and we're going to multiply that by, it is 1.535 times 10 to the minus 2 moles of HCl per liter. Liters cancel, and that tells us the number of moles of HCl that are needed to take it to the end point. Now, at this point, we're going to focus on the actual, what we call the stoichiometry. What's the ratio? And this is actually a molecule that is built a little bit like this, and it's got 2 places where that hydrogen plus will react. And so you see it's going to take 2 atoms of H plus for every 1 atom or 1 molecule of B to react. That's what we're saying up here. There's a 1 coefficient there. There's a 2 coefficient there. So let's say if we have 0.25 moles of HCl, because we know it is 2 moles HCl for every 1 mole of base, that's going to cancel, and it's going to be 0.25 divided by 2 are the moles of base. That's all. That comes from the stoichiometry, the ratio of how many of 1 molecule are needed to react with the other molecule. And in this case, it is 2 to 1. And that will allow you to look at, so that's question 1, moles of HCl. Pretty straightforward calculation. I'll go ahead and add question 2. Question 2 is moles of B titrated. And that just means I'm doing a titration. That's what this reaction is. It's a titration. And if it takes this many moles of HCl, how many moles of B? And that's the question. That's it. And then you go down, and then once you know how many moles, it tells you what the mass is, and you can figure out molar mass and that sort of thing. But that should get you going. That's really the only tricky part here. And that's all we're doing in this lab, is doing a titration that's very similar to last week, except in this case, there are 2 moles of HCl for every 1 mole of the base. Okay, good luck. We'll talk about this Monday in class.